obviously, my talk is a subset of what is called traditional complementary medicine. I am second to none in my belief that traditional and complementary medicine is riddled with hearsay, confirmation bias, and superstition. It is my very strong opinion that 95 or maybe even 99% of traditional medicine is nonsense and bogus. But that does not mean that all of it is junk. And my kind of idea about this is when we dismiss it, we shouldn't be throwing out the baby with the bathwater when it comes to traditional medicine. Before we start, I have a brief exercise. Humor me for this. I wanted to do 45 seconds, but let's just do 30 seconds. I have my watch right here. Can you blank out your mind and basically have no thoughts whatsoever? Go. And I would say here, I would guess that unless some of you are endowed with extraordinary powers of concentration, most of you would find that pretty tough. Because the common experience is that even if you want to think about nothing, some thoughts are always going to intrude upon your consciousness. And it's like when you tell somebody not to think about an elephant, the first thing they would think about is an elephant. So this phenomenon where essentially thoughts intrude upon you even if you don't want them to has been described in several ways. I went to one of these meditation classes once in Chicago where they described it like this, as clouds flitting across a blue sky, essentially saying that something's always moving. And the other way it's been described is as a still lake but with ripples forming on it because of droplets of water. So the image that is being conveyed by both of these is a essentially flat surface which is continuously in motion because of some activity. So, which I think is very fascinating because this ties in very closely to a definition for yoga that was given in this book called the Yoga Sutra in 200 AD. Yoga Chitta Vritti Nirodha, which translated essentially means yoga, mind whirling, stop it. So yoga was defined as a practice to stop your mind from moving around. So yoga and meditation are basically defined as practices for better mental control. Their basic premise is that your nervous system can be changed with repetitive effort. It's kind of like saying that your mind is a muscle and you exercise it, it can grow stronger. There's several practices of yoga and meditation throughout the world. There's common themes to all these practices, but each of them may emphasize a different area. So I have addressed them in combination because I think it is very difficult to get individual information about each practice. So I would say the first thing that I'd like to talk about is the effects on brain structure, which as neurologists, we are of course something which we deal with every day. Here's one MRI study from the National Institute of Health and the McGill University, published in 2015 in Frontiers in Human Neuroscience. They looked at 14 yoga practitioners versus 14 controls. They looked at whole brain gray matter. In most normal people, there is a significant decline with age in whole brain gray matter, and they found this in their control as well. However, they did not find a significant negative relationship in the yoga group. So this graph basically represents that. The open circles are the controls and the closed black dots are the yoga group. So no significant relationship. Even more interesting, a greater duration of yoga practice actually led to increased cortical gray matter in 4 areas in particular: left orbital frontal, left insula, the frontal operculum, and the right temporal lobe. And moving on from structure to function, looking at brain networks, the best studied, of course, is the default mode network, which is one of the resting state networks. And this is a network which is something which is active when you are at rest, basically just sitting there maybe with your eyes closed, not thinking about anything. It is supposed to be involved in processes such as self-related thinking, introspection, social cognition, and mind wandering. Increased activity of the default mode network, as represented in this figure, has been found in autism, schizophrenia, and depressive rumination. So those of our friends from psychiatry who deal with these people on a daily basis, they can see that People with depression and schizophrenia, for instance, seem to have a lot of things going on. Their inner voice is very strong. In schizophrenia, you hear multiple inner voices. In depression, your inner voice is very strong and keeps telling you that something is wrong with your life and so on. At the same time, you can see decreased activity of the default mode network in a few conditions. Alzheimer's disease is prominent amongst the stuff that we do on a daily basis, and normal aging as well. When it comes to meditation in the default mode network, the fascinating finding has been that open monitoring meditation decreases default mode network activity and connectivity. In fact, it has been proposed in some studies that the default mode network can be used as a biomarker for the efficacy of open monitoring forms of meditation, primarily like mindfulness meditation. Also interesting is that antipsychotics and antidepressants have both been shown to decrease default mode network connectivity, and the decrease correlates with the degree of clinical improvement. But then you might ask, what about Alzheimer's and aging, where the direction of problem in the default mode network is the opposite, where there's actually decrease to begin with? And it has also been shown that donepezil can stabilize or increase connectivity in Alzheimer's. And I think here the interesting finding is that certain forms of meditation, primarily the focused attention sort, where you're kind of focusing on one object, increases connectivity in the default mode network as opposed to what you see in open monitoring. Again, different forms of meditation seem to have different effects on different parts of the nervous system. Moving on to our third subject of EEG changes, which of course a lot of people in this room deal with. One systematic review of 56 studies of meditation comprising 1,715 subjects published in Neuroscience and Biobehavioral Reviews found that overall these studies found enhanced alpha and theta power. For those of you in this room who are not epileptologists, alpha, beta, theta, they're all like bands in the EEG about frequencies. And alpha is thought to represent perhaps relaxed and internally directed attention. Theta might indicate perhaps relaxation. You can see it in sleepiness. You can also see it over the hippocampi, sometimes in spatial cognition, memory consolidation. The other fascinating finding, though, has been this British study, which looked at 3 different meditation and yoga traditions. That graph on the right, the blue line on the bottom is EEG power in controls. The 3 colored lines on the top are 3 different meditation and yoga traditions. They found increased gamma activity, which is very high frequency activity, which we don't really look at on a routine EEG usually, over the parieto-occipital areas. The kind of catch here was that this comprised only advanced practitioners, and this finding has also been noted in other researchers' publications, where the increase in gamma is primarily detected in people who have been meditating for 10 or 20 years. So, as I've shown in the previous slide, where a greater duration of practice seemed to correlate with increased structural change, it appears that EEG changes also are more prominent in people who've been meditating for longer times. And the fourth subset of neurology where there has been investigation of the effects of meditation yoga has been the autonomic nervous system. And here I would like to talk primarily about 2 approaches. One is heart rate variability. Heart rate variability, essentially, the idea behind that is that more variability in your heart rate from minute to minute or second to second indicates a higher parasympathetic tone. Your vagus is acting more on your heart. The other way that people have assessed this is galvanic skin response, where essentially you're looking at the conductance of your skin. And the theory behind this is that increased galvanic skin response is seen in higher sympathetic states, possibly because when you have more sympathetic activity, you're sweating more, and your sweat has salt and water in it, so your skin is more likely to conduct electricity. So the initial belief was that all meditation techniques cause relaxation and parasympathetic dominance. And of course, a lot of early studies did confirm this. They found decreased oxygen consumption, decreased arterial blood activity, decreased respiration, decreased pulse rate. For instance, this 2009 randomized control trial in the Proceedings of National Academy of Sciences showed that just 5 days of intensive meditation reduced galvanic skin response and increased heart rate variability. Again, less sympathetic, more parasympathetic. However, again, the catch here was that most of these studies were done on open monitoring forms of meditation. In other words, one subset of meditation. There have been a few other studies that have shown that some variants of meditation can elicit arousal, increases in heart rate, increases in galvanic skin response. And you might be justified in asking what the point of that is. Like, isn't the entire point of meditation to calm yourself down and just be like really relaxed? But these studies also show that people who did these forms of meditation that increase showed a dramatic improvement in performance on cognitive tasks, especially those requiring visual attention. However, of course, the long-term effects of these is not known, and which kind of intuitively makes sense, because if you had to solve 20 very difficult math questions, you would prefer to drink a cup of coffee and be more aroused as opposed to take like Valium or Propranolol and just very chilled up. And here's a fascinating trick that you can employ at your next party. This very complicated graph, the x-axis prevalence time intervals, the y-axis is core body temperature. For these the investigators from MGH in Singapore, they went to Tibet, I believe, and published this last one. Just 4 meditators. One of them was able to raise their core body temperature seated in one place, purely breathing and focusing on something, from 36 to over 38 degrees Celsius, so into the fever range. And this has been traditionally it has been called as a practice which you use to dry a wet cloth that is wrapped around you. But this was perhaps the first indication that something like this is actually physiologically possible. And moving on to another very important topic, emotion processing. A lot of studies have been done on anxiety, depression, and pain, and even though we have some of our psychiatry friends here, I'm not going to go into that because it's not purely neurology related, and at the same time I find it a little bit hard to tease out the effects of placebo and suggestion from actual outcome. So, but I will talk about this Russian study using event-related potential, which is something you find on EEG. Essentially, they gave people emotional stimuli, and they looked at the EEG spike in response to it. They looked at 20 meditation yoga practitioners versus 20 controls, and they found that in the practitioners, the early event-related potential response was attenuated when you gave them emotional stimuli, but the late response was unchanged. So their hypothesis is that perhaps intensive meditation and yoga practitioners are able to shift from an automatic response to emotional and arousing stimuli to a more cognitive appraisal, where you kind of step back and let your higher order cognition handle a stressful situation. And here I would like to take a brief interlude by showing you the picture of this man and telling you his story. I don't think anybody here probably knows him except perhaps Minnie, because her sister works with this guy. This is Ray Dalio. He's the chairman of Bridgewater, the world's largest hedge fund. Ray Dalio started Bridgewater from his apartment in 1975, and today he manages $150 billion. And as you can imagine, running a hedge fund is a very difficult job. He described it in an interview as some people described working at Bridgewater as being like an intellectual Navy SEAL, because you're just making all these very, very high-value decisions on the fly with very limited information. It's very difficult to predict the future, and you can't afford to get biased by emotions or your boss yelling at you or what your wife said to you this morning. So Business Insider carried this very fascinating article last year, Transcendental Meditation, which Bridgewater's Ray Dalio calls the single biggest influence on his life, is taking over Wall Street. Perhaps both because people on Wall Street are very stressed, and also because maybe they want to make really good decisions without being affected by their emotions. So, which ties into this next point that I'm getting into, which is cognitive ability. A 2014 study from Mass General, they looked at 16 yoga practitioners, 16 meditators, and 15 controls. They were well matched for all traits, including for intelligence. And they found that fluid intelligence declined slower in aging yoga and meditation practitioners. And this is kind of a graph showing that, as you see, the lower curve is controls decline more over age, the two upper curves is yoga and meditation practitioners. And they believe, based on the MRI studies that they did, that this was mediated through greater integration of resting state networks in the people who were yoga and meditation practitioners. And there are closely related fields, which is perception, attention, executive function. a randomized controlled trial from the University of Illinois of 118 sedentary adults. 8 weeks of yoga versus 8 weeks of stretching, they were randomized into these two groups. The yoga group had better executive function, and this was mediated by lower salivary cortisol. Now, it has been suggested that the frontal lobe is sensitive to prolonged activation of the hypothalamus pituitary adrenal axis. And it has also been shown that stressful tasks can increase salivary cortisol. It is interesting here that yoga did not lower pre-stressor cortisol levels. So essentially, this practice did not seem to essentially make you less stressed per se. It made you less stressed when something stressful happened to you. It made you less reactive. In other words, this can be described as perhaps smaller ripples in the pool, like that GIF I showed you of your mind as a pool with ripples on it. Like this fascinating study from the University of Wisconsin, 17 participants and 23 controls, before and after 3 months of meditation. They gave them 2 successive stimuli, like poop, poop, and their job was to identify both stimuli came. As you can imagine, this is quite tough because when you have one stimulus, your brain kind of gets wrapped up in that. It's usually refractory. You can't really respond to the other one in time. And they assessed event-related potentials on EEG for each of these stimuli. And they found that after the meditation retreat for 3 months, people were able to better identify the second stimulus. And this was mediated through reduced amplitude of the event-related potential response to the first stimulus. This very complicated graph essentially indicates that on the x-axis is the reduction in the amplitude of the response of ERP to the first stimulus. On the y-axis is the amount of accuracy in detecting second stimulus. The red circles are the practitioners and the blue squares are the novices. So essentially what they're saying here is that practitioners were better able to detect the second stimulus, even if it was present very close to the first one. And those who suppressed their ERP response to the first one most were the ones who were most likely to pick up the second one. So essentially, again, they were hypothesizing that this may represent a more efficient allocation of the limited resources that your brain has. And of course, finally, postural exercises. Now, when we talk about yoga, this is the first thing that comes to everybody's mind, not necessarily something which involves focus or thinking. And here, I would have to say that the amount of research is quite limited because it is very hard to tease out the effects of this alone, independent from all the cognitive breathing and chanting and all the other stuff that goes on. But there is some evidence that your physiology and your body can affect your cognitive functioning. In philosophy, this theory is known as embodied cognition, and one very fascinating theory in this field is that called the somatic markers hypothesis. This was put forward by Antonio Damasio and his colleagues. Antonio Damasio is a Portuguese neurologist. He currently works at the University of Southern California. He basically postulated that emotional processes guide behavior. He says that emotionally charged events, maybe your heart's beating fast or breathing quicker, these are remembered in some structures of your nervous system, either in your spine or your brainstem or your insula, and then these remembrances are kind of drawn when you are making decisions sometime in the future. I'm going to give you a series of pictures. I want you to tell me which one you think is the boss or which one is probably less stressed, which one is happier. That's a couple of gorillas. Okay, and 2 cartoon figures, not humans at all, like just human animations. 2 monkeys. And here, I've removed all visual cues, so you can't really pick up anything else. It's pure stick figures, a line diagram. Only difference being the posture of the neck and the thorax and what you call the core musculature. And I think the impression that you can draw from this is even us as third-person observers of these figures have the impression that somehow the ones which are kind of hunched over and kind of weak-looking are sadder, probably less, are probably more stressed. And that's why I was really intrigued when I read this article in The Atlantic last year. Why one neuroscientist started blasting his core. For those of you who don't spend much time in the gym, the core is supposed to be like this one. So the subtext was a new anatomical understanding of how movement controls the body's stress response system. And this wasn't just a journalist writing it. It was James Hamlin. James Hamlin is an MD from UCLA and a radiologist who is now a reporter for healthcare related to The Atlantic. So this article was based upon this study published in Proceedings of the National Academy of Sciences in 2016 from the University of Pittsburgh Medical Center, where they used transneuronal transport of the rabies virus, which, the rabies virus moves across neurons, so you can use it to check what neurons are connected to one another. And they identified two paths from the motor areas, the motor cortices, to the adrenal medulla, from the frontal, prefrontal, and cingulate area. This was kind of like the money sentence, you might say. We found that the top-down influence over the adrenal medulla by M1, the primary motor cortex, originates largely from its trunk representation. This region of M1 projects the thoracic segments of the spinal cord. So again, like this part of your body, the part of your motor cortex that projects there has direct connections to the adrenal medulla. So this is kind of the end part of my talk. So this is, of course, a representation of the nervous system. I came into neurology and neuroscience per se because I was very fascinated by the nervous system, how it works, and everything that it does. Once I've spent a fair amount of time at UAB in the hospitals, I kind of understood 6 broad ways of looking at the nervous system, or 6 schools of thought, you might say. One, of course, is neurosurgery, where you're treating the brain as basically a lump of flesh, manipulating it. Anesthesia, where you're dealing with a very global picture of the brain, where you're giving people anesthetics to completely damp down their function and then bring them back up again. Neurology probably comes next. We break the brain into like certain subfields or modules and then deal with them individually. And then that person is Ivan Pavlov. Ivan Pavlov is the person who came up with classical conditioning, the famous experiments with the bell and the dog and the salivation. So he was a physiologist, a neurophysiologist who looked at behavior. So moving a little bit into the subjective realm of things, looking at behavior, but still looking at it in a very objective third-person view. And that person, in case some of you don't recognize him, is Carl Jung. Carl Jung was a psychiatrist, very, very subjective in his approach to the nervous system. And then finally, in my opinion, comes things like meditation, which are also very radically subjective and deny essentially the third-person view. And it is my strong understanding or my strong belief that each of these approaches to the nervous system has something to contribute. It is very difficult to grasp the entirety of the functioning of the nervous system purely through one approach. Because no matter how many times you cut open somebody's skull or pull out a clot, you're not going to be able to explain the subjective first-person experience. And vice versa, like no matter how much you do meditation or yoga, it's not going to save you when your MCA is blocked up. So, in essence, what I'm trying to say here is that there are multiple approaches to understanding the nervous system. Not all of them have the entire truth. It is my hope that with greater integration, our understanding will improve. And my feelings, though, are kind of summed up best by this very small poem from a famous American poet. We dance round in a ring and suppose, but the secret sits in the middle and knows. This was by Robert Frost, and I think that really captures my opinion of how all these ways of looking at the nervous system may or may not get us to the ultimate truth, but it's something we can try.